Hi everyone. Today's lesson is going to cover the topic of the mole ratio. So we're going to look at ratios and how they pertain to moles within a compound. Now this is lesson 2.7. 2.7. Okay, so first of all, what is a ratio? So sometimes I talk about these things and then I realize, do people actually know what a ratio is? A ratio is just comparing two things to each other, or it could be more things to each other. It's a quotient. You can think of it as a division too. These are all sort of the same things. So for example here, just this first one here, we've got 3 red dots to 1 blue dot. So the ratio is 3 to 1. Here we have 1 to 4 as a ratio. This one 2 to 3. And this one we've got 3 different things. So that's going to be 1 to 2 to 1. Okay, so we can describe how these are compared to each other by using a ratio. Now, we are going to apply that to chemistry here. So we're going to look at HCl here. So 1 mole of HCl, so this would be a compound or binary compound, hydrogen chloride. If I have 1 mole of HCl, how many molecules do I have if I have 1 mole of that? Yeah, so hopefully you came to the conclusion that you've got 6.02 times 10 to the 23rd molecules here. Now, within this molecule, so remember the molecule is the whole thing, I have hydrogen atoms and chlorine atoms, right? So how many atoms do I have? If I've got 6.02 times 10 to the 23rd molecules, how many hydrogen atoms are there going to be? And it's going to be 6.02 times 10 to the 23rd hydrogen atoms, and the same is going to be true for the chlorine atoms. So again, 6.02 times 10 to the 23. If you think about this in terms of people, so let's say you had a dozen people, so a dozen being 12, right? Looking at this little person, they're representative of all of them. If you have a dozen of those people, how many noses do you have? 12, right? Because 12 people, you're going to have 12 noses altogether. And that'll make more sense in a minute here. So in 1 mole of HCl, there's going to be 1 mole of hydrogen atoms and 1 mole of chlorine atoms, okay? And that's where these numbers come from here. Now, what about if we look at lithium sulfide? So you need to be able to write the compound here. So lithium is 1 positive, sulfur is 2 minus. So these are going to bond in a 2 to 1 ratio here. So I've got 2 lithiums for every 1 sulfur. Now, if I've got 1 mole of lithium sulfide, how many molecules do I have? And that's going to be 6.02 times 10 to the 23rd molecules. Now, how many, let's do sulfur first actually. So within this molecule, how many atoms of sulfur do we have? And that's going to be 6.02 times 10 to the 23rd. So this would be like the noses, right? But, so let's go back to the people for a second. Let's look at our people. If I asked you, you got a dozen people, how many eyes are there if you have a dozen people? So you would say 24 then, right? So instead of the 12, you have to multiply that by 2 because of course we have 2 eyes for the most part. So lithium atoms here, so just make a note here that lithium is not just 1 in there. The ratio has changed, so it's not a 1-to-1 ratio anymore, it's a 2-to-1 ratio. So for lithium atoms, I'm going to have 2 multiplied by the 6.02 times 10 to the 23rd. So that's how many lithium atoms I will have. And so verbally, this is the wrong thing here, Li2S, in 1 mole of lithium sulfide, there are going to be 2 moles of lithium atoms and 1 mole of sulfur atoms, okay? So the ratio here, 2 to 1. So for example, let's look at magnesium chloride. Magnesium chloride is going to contain magnesium and chlorine. And magnesium, we're going to have 1 mole. Chlorine, we'll have 2 moles of chlorine within 1 mole of magnesium chloride. Now, 1 mole of H3PO4 is going to contain hydrogen, phosphorus, and oxygen. So within that, we've got 3 moles of hydrogen. We've got 1 mole of phosphorus, and we've got 4 moles of oxygen within the compound H3PO4 here. Okay, so I'm gonna just change this. Sorry, this was a typo. Determine the moles of chlorine ions in 0.563 moles of calcium chloride. So we're going to use our dimensional analysis to figure this out. Now, one thing to note here, calcium chloride, calcium is 2 positive, chlorine is 1 minus, so the formula, chemical formula is going to be CaCl2. So again, we're setting up our DA here. So I'm looking for moles of Cl minus. Okay, so the chlorine ions is Cl minus equals, what do I know? I know that I have 0.563 moles of calcium chloride. So now I'm going to draw my conversion factor. Now moles of, this is why it's important to be detailed and put in like the calcium chloride here, because it gets confusing otherwise. So moles of calcium chloride goes on the bottom. Moles, this one here, moles of Cl minus is going to go on the top. And then I need to figure out what is the ratio between those two things. So I know by looking at, if I look up here, I know that I've got 2 moles of chlorine for every 1 mole of calcium chloride. Sorry, calcium chloride being the whole thing. So 2 moles of chlorine is going to be inside 1 mole of calcium chloride. So the ratio here is going to be 2 to 1. And then I can work that out. So I'm going to say 0.563 times 2 is going to be 1.126 moles of Cl minus, but I have to pay attention to sig figs. I can only have 3 sig figs, so I'm going to use a bar over top there, or I'm just going to round it to 1.13 moles of chlorine minus. Okay? Excuse me. Okay, next example here. Determine the number of moles of each atom in 3 moles of sodium phosphate. So again, right away you have to make sure you know how to write the compound. So sodium phosphate is going to be Na3PO4. Now, you don't actually need, like I can look at this right away and I can say I'm going to have 9 sodiums, 3 phosphorus, 12 oxygen. But I'm going to write the dimensional analysis just so that you really get used to managing that. But just so you know, like if this was your own work, you wouldn't have to write it out. If you can just do that in your head, clearly go ahead and do that. So moles of each type of atom. So first of all, I'm going to go moles of sodium equals, again, I know that I've got 3 moles of the sodium phosphate. So looking at that, moles of sodium phosphate goes on the bottom, moles of sodium goes on the top, and the ratio between those is going to be 3 to 1. And this is where my 9 moles of sodium comes from, okay? And again, these things are going to cancel here. Next, I'm going to do phosphorus, so moles of phosphorus. Again, what I know is 3 moles of Na3PO4, and then moles of Na3PO4 on the bottom, moles of phosphorus on the top. Now I look back to my entire compound here, Na3PO4, I know that I've got 1 phosphorus in that whole thing, so the ratio 1 to 1 there. So 3 moles of phosphorus. And then lastly, of course, moles of oxygen. Again, I'm starting back at the starting point here, 3 moles of Na3PO4. And then that's going to go on the bottom. On top is going to be moles of oxygen, and the ratio between those, you've got 4 moles of oxygen for every 1 mole. And this is where I get my 12 moles of oxygen. Okay, so that's how you do that. That's pretty basic. It always makes more sense when it's whole numbers, right? Instead of decimals. Okay, now we're going to take this one step further here. Whoops. So calculate the number of moles of potassium in 3.6 grams of K2SO4. So of course the difference here was that prior to this, this information was given to you in moles, but now it's given to you in grams, okay? So we're going to set up our DA though, back, like always go, what are you looking for equals what do you know? So you're looking for the number of moles of potassium. So moles of potassium equals, what you know is that you've got 3.6 grams of K2SO4. So looking at this, now your very first step is going to be to convert that grams. You need to get rid of the grams, so grams goes on the bottom, K2SO4. Now, what goes on top? Now, when we're dealing with molecular masses, and you learned this the other day, the mass is going to be on a per mole basis, right? So in 1 mole of K2SO4, how many grams are there? And you can go to your periodic table and add this up. It's going to be 2 potassiums, 1 sulfur, 4 oxygens, and you will get, if you add those up, 174.3. Now that number came from the periodic table, okay? And it has to come from the periodic table. Quite often I see people trying to put this 3.6 grams back in there. That's not where it goes. In terms of your conversion factor, that has to come from the periodic table. So if you stopped your problem right now, you will note that grams of K2SO4 cancels, and you're in moles of K2SO4. You don't want moles of K2SO4 though, you want moles of K. So you're gonna need another bracket, and now moles of K2SO4 goes on the bottom, and moles of potassium goes on the top. And now we're going to look at our mole ratio. This is called the mole ratio. When we compare mole to moles, that is our mole ratio. And so we've got 2 potassiums for every 1 mole of K2SO4. And if you do the math on this, you end up with a value of 0.0413 moles of potassium, but I can only have 2 sig figs. I'm going to put the bar over there, or just round that to 0.041 moles of potassium. Okay, and those are all done the same way. The only thing you have to remember is that in chemistry, we always work through the mole. This is a mole animal, which I think they're blind. I don't think they have eyes. They're nocturnal. Anyways, I should know more about moles. This you need to write down. You need to know that. So basically, if you're given grams, your first step is always going to be convert that into moles. You cannot go directly from grams of something to moles of something else. You always have to convert through the moles. I always say it's kind of like if you're on Seaford side and you want to go to the Maple side, you have to go through the bridge or the commons at some point, right? You can't just, or the link, I guess. You can't just bypass that area. You have to go through it. And the same is true for moles. You always have to go through moles. So I'm going to get you to try exercise 10 and number 11. And yeah, give those a try. Again, you have the answers, so see how you do, and then be ready to come to class and ask your questions. Okay, thanks.